So there's several ways that we can represent molecules. We can represent them as Lewis structures. Lewis structures show every atom and show every bond. We can also show molecules as a partially condensed or a condensed structure. Here, atoms are grouped. Or we can have a molecular formula. The problem with a molecular formula is that it can refer to more than one molecule. It gives the least information. In the study of organic, we'll probably be using the bond line structures the most. With these structures, there's a carbon at each end and at each of the corners. So let's see how this works. If we wanted to draw this compound as a bond line structure, we have 1, 2, 3, 4, 5, 6 carbons. We would draw this. There's one carbon on each end, and then there's a carbon at each one of these corners, and that makes 6. If we wanted to do the next one, we'd have, with the methyl group coming off here. So this carbon is there, this carbon is there, this carbon is here, this carbon is here, and these two carbons are here and here. If we wanted to draw this one, we could draw now, to draw the ethanol, we would draw 2 carbons, one here, and then we have another line. This line goes to the oxygen, and we would draw this hydrogen. Note, I haven't drawn any of the other hydrogens. The only hydrogens I'm going to draw are the ones to non-carbon atoms. Okay? So if we wanted to draw the Lewis structure for this compound, we would draw carbon with 2 hydrogens, and it's double bonded to the carbon next to it. The carbon next to it has 1 hydrogen and is bonded to an oxygen. It's bonded to a carbon with 2 hydrogens. We're here now. Bonded to a carbon. This one has a hydrogen on it. And this means that there are 2 CH3 groups. Those are methyl groups. So there's 2 methyl groups. So we'd have a C. And if we're going to draw all of the bonds, we have to draw. And then we have another methyl group here. So let's look at the bottom example here. For the following molecules, determine the number of carbon atoms present and then determine the number of hydrogen atoms. So I'm going to get a different color pen. We know that there's a carbon atom at each end. So that's 3. And then each one of these corners has a carbon. So we've got 1, 2, 3, 4, 5, 6 carbons. Now, each carbon atom has 4 bonds. But we don't show the hydrogens. So I'm going to draw like little lines just to show where the hydrogens would be. This is a terminal carbon. It needs to have 4 bonds, so it's got 3 hydrogen bonds that are not shown. This carbon has 2 bonds, so it has 2 hydrogens. This carbon has 2 bonds, so it has 2 hydrogens. This carbon has 3 bonds, and so it only has 1 hydrogen. And these two are both terminal carbons, and so they've got 3 hydrogens coming off of them. So if we count all these up, we get hydrogen 14. Okay, so this one's a little more interesting. First, we're going to count carbons. Got a carbon here, carbon here, carbon here, carbon here, carbon here. All these ends are carbons, and then all these bends are carbons. So that gives us 12 carbons. And then let's figure out our hydrogens. The carbons that are in the ring have 1 bond that goes to this methyl group. They have 1 bond to the carbon behind them, and in this case we've got a double bond to the carbon in front. So it already has 4 bonds. There are no hydrogens on these ring carbons. There are hydrogens, though, on these carbons that are out here. Each one of these has 3 hydrogens. And we know that because each carbon's going to have 4 bonds, and these carbons that are on the outside only have 1 bond. And that will give us 18 altogether. There's 6 of them, and each one has 3, so that's 3 times 6 and gets 18. Okay, so let's look at the carbons here. We've got carbon here, 1 here, 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 and here. So that's 6 carbons. And now let's count our hydrogens. Well, this carbon has 2 bonds, so it's got 2 hydrogens coming off of it to give it 4 bonds. This carbon has 2 bonds, so it's got 2, and this one as well. This carbon has a bond to the carbon below it and a double bond to the carbon above it, so it's got 3 bonds. So it's got just 1 hydrogen. And this one is in a similar position, because it has that double bond. This carbon is double bonded to the oxygen and has a bond to each of the carbons, so it has no hydrogens. So we count these up, we get 2, 4, 6, 7, 8.